didn't arrive with a warning. No alarm, no headline, no urgent press briefing. It showed up the way the universe usually does, quietly, almost politely, as a faint irregularity buried inside routine data. A tiny movement across deep space that didn't belong where it appeared. Just a blip at first, easy to ignore, easy to explain away. At least, that's what everyone thought. The object was first flagged by automated sky survey systems designed to catch near-Earth asteroids, the kind that scan the sky every night without emotion, without curiosity, just numbers and motion. But this one didn't behave like the others. Its speed was wrong. Not fast in a dramatic way, but precise, controlled, almost careful. At first, it was labeled as another interstellar visitor, a third one, actually. After Oumuamua in 2017 and Borisov in 2019, astronomers were starting to accept that objects from other star systems pass through ours more often than we once believed. Space, it turns out, is not as empty as it looks. But this object refused to sit quietly inside that explanation. Its path through the solar system didn't look like a rock flung randomly through space. It didn't dive in and sling away. It coasted, smoothly, patiently, as if it had time, as if it wasn't in a hurry. That alone raised eyebrows at places like NASA's Jet Propulsion Laboratory, where trajectory modeling is treated almost like a religion. Gravity leaves fingerprints, every planet pulls, every star tugs. But when scientists ran the numbers again and again, the math kept coming back uncomfortable. The trajectory was too clean, too efficient, too intentional. When astronomers traced its path backward, hoping to locate its origin, the results got stranger. It didn't point to the Kuiper Belt. It didn't come from the Oort cloud. It didn't even line up with the chaotic scattering patterns expected of debris kicked loose during planetary formation. It came from interstellar space, deep interstellar space. Not just between stars, but from a region where stellar density is low and travel times stretch into tens of thousands of years, which raised a quiet but unavoidable question. Why now? Before 2017, we had never detected a single confirmed interstellar object. Then, suddenly, 3 appeared within a decade. And each one was stranger than the last. This one was named 3I Atlas, a sterile label for something that was quickly becoming anything but. When the James Webb Space Telescope was brought into the conversation, the tone changed. Webb wasn't built to chase rumors or entertain speculation. It was designed to measure reality at its faintest edges: heat, chemistry, structure, truth, written in infrared light. When Webb turned its instruments toward 3I Atlas, the first results didn't trigger panic. They triggered silence. The thermal data didn't behave like ice or rock. Comets heat unevenly as they approach the Sunday asteroids, warm slowly and predictably. 3I Atlas didn't either. Instead, it showed rhythmic heat variations, not chaotic spikes, not random noise, a pulse, slow, repeating, measured. Every cycle was nearly identical to the last. At Harvard Smithsonian Center for Astrophysics, researchers compared the signal against known natural processes: solar radiation, rotational heating, outgassing models. None of them fit. The pattern wasn't breaking down, it wasn't decaying, it wasn't reacting the way inert matter should. It was maintaining itself. Even more unsettling was what Webb didn't see. There was no visible propulsion, no plume, no tail, no debris trail, no measurable exhaust of any kind. And yet, the object's motion showed subtle deviations, tiny course corrections that could not be explained by gravity alone, the same kind of non-gravitational acceleration that made Oumuamua famous, but more stable, more refined, almost practiced. At the European Southern Observatory, astronomers began cross-referencing older datasets, archival telescope records, infrared sweeps, even legacy data from Arecibo's radar observations before its collapse. That's when the frequency appeared. A faint electromagnetic signal repeating at regular intervals. Low bandwidth, weak enough to hide beneath background noise, but persistent, The interval was exact, 147 seconds. No known natural object produces a signal like that without an internal energy source. And 3I, Atlas, showed no signs of 1. When that frequency was compared to historical data, something else surfaced. The same frequency had been detected once before. Briefly, years earlier, in the fading data stream of Oumuamua, back then, it had been dismissed as interference, instrument noise, a statistical ghost. Now it looked more like a whisper repeated twice, and whispers are rarely accidents. And NASA's Deep Space Network, engineers noticed something else. Whenever Webb adjusted its observation window toward 3I Atlas, the signal subtly changed, not in strength, in structure. The spacing between pulses shifted by fractions of a second, then returned to baseline. It was as if the object noticed it was being watched. That idea made people uncomfortable, not because it sounded impossible, but because it sounded familiar. Stanford physicist Ronald Bracewell once proposed that advanced civilizations wouldn't broadcast loudly into space. They'd send probes, silent ones, observers that wait, watch, learn, and only respond when recognition occurs. No one said that theory out loud in official meetings, but it didn't need to be said. The room felt it. Webb's spectrograph then delivered the detail that pushed this from curiosity into unease. The surface composition of 3I, Atlas, didn't match known asteroid classes. The reflectivity was too high in some bands, too low in others. Certain wavelengths were absorbed entirely, as if swallowed. Complex carbon compounds appeared in structured arrangements, not the chaotic mix expected from natural formation. These weren't simple organics drifting through space. They were ordered, refined, grown, or built. At Keck Observatory in Hawaii, adaptive optics confirmed faint geometric regularity along parts of the surface. Not sharp edges, not obvious machinery, but symmetry, repeating ratios, fractal-like scaling that mirrors patterns seen in biology and advanced materials science. Nothing about it screamed spaceship, which somehow made it worse. Because whatever this was, it didn't look like something made for us to recognize. And that raised the most disturbing possibility of all. Maybe we weren't the audience. Maybe we were the environment. The more scientists tried to pin 3I Atlas down with familiar language, the more it slipped away. Asteroid didn't fit anymore. Comet never really did. Even probe felt too simple, too human. Whatever this object was, it didn't behave like something that had been thrown into space. It behaved like something that had learned how to move through it. At NASA's Jet Propulsion Laboratory, trajectory simulations were run again. This time not just projecting where the object was going, but how it reacted to forces along the way. Solar pressure, planetary gravity, magnetic fields. Each factor was isolated and reintroduced, one by one. And every time, the same quiet anomaly remained. 3I Atlas adjusted itself. Not dramatically, not enough to raise alarms on its own, but enough to matter. Enough to suggest feedback, like a sailor trimming sails, not fighting the wind, but working with it. What disturbed analysts most was not the adjustments themselves, but the timing. The corrections happened at moments when the object passed through regions of increased observation, when ground-based telescopes in Chile came online, when Webb shifted its mirror alignment, when radar systems briefly swept its vector. The pattern wasn't obvious. It was subtle. But once seen, it was impossible to unsee. The object reacted most strongly when attention increased. That didn't mean it was responding to us directly. It could have been reacting to something else entirely. But either explanation was unsettling. As word spread quietly through research circles, the comparisons to Oumuamua began to change. In 2017, that object had baffled scientists with its lack of outgassing and unexplained acceleration. Avi Loeb from Harvard had famously suggested it might be artificial, a claim that split the scientific community in half. Most dismissed it. Not because the idea was impossible, but because it was uncomfortable. Now, years later, with better instruments and more data, some of the same skeptics were revisiting those arguments. Not publicly, not yet, but privately, in emails and closed meetings, the tone was different. Oumuamua no longer looked like a fluke. It looked like a prototype, and 3I Atlas looked like a refinement. Unlike Oumuamua's chaotic tumble, this object rotated slowly and consistently. Its spin rate remained stable even as it passed through varying gravitational environments. That alone suggested internal mass distribution that had been deliberately engineered, or at least carefully shaped. At the Vera Rubin Observatory, still preparing for full operations, simulation teams tested how such an object could maintain stability over interstellar timescales. The results were sobering. Natural bodies tend to degrade. They fracture, they spin apart, they erode. This one hadn't. If it had been traveling for tens of thousands, or even millions of years, it had done so without losing coherence, without shedding mass, without becoming noise. That level of endurance implied either material science far beyond ours, or something that could repair itself. Both possibilities carried weight. Meanwhile, Webb continued its observations. Not continuously, but in carefully timed intervals to avoid overwhelming its instruments. Each pass added clarity, not answers. Infrared readings showed temperature gradients beneath the surface that didn't align with external heating. Heat appeared to move laterally inside the object, flowing around internal structures rather than radiating outward. That suggested channels, layers, compartments, hollow regions. When those findings were compared to data from the Hubble spectrograph, something unexpected emerged. A faint absorption pattern at wavelengths associated with complex polymers. Not plastics as we know them, but long-chain carbon structures with repeating units. On Earth, similar signatures appear in advanced composites and biological scaffolds. Nature rarely builds those cleanly. At the European Space Agency, a small team began referring to the object as a system rather than a body. That choice of word mattered. Systems imply interaction, purpose, internal logic. Bodies simply exist. What made the situation more complicated was the object's silence. There were no broad transmissions, no radio beacons, no bursts designed to announce presence. The electromagnetic pulses were narrow, quiet, and directional. They didn't feel like messages meant to be heard. They felt like telemetry, data being sent somewhere else. When analysts attempted to trace the vector of those emissions, they found something deeply unsettling. The signals were not aimed at Earth. They were angled outward, back along the object's incoming path toward interstellar space. If 3I Atlas was reporting, it wasn't reporting to us. That realization shifted the conversation entirely. This wasn't contact, it was observation. And observation implies hierarchy, as if the universe hadn't suddenly noticed us, but had always been aware, waiting for the right conditions to take a closer look. Then came the redirection. It wasn't announced. It wasn't dramatic, just a tiny shift, barely visible in the raw data. But when trajectory models were updated, the difference became clear. 3I Atlas had altered its path, not enough to threaten Earth, not enough to trigger public concern, but enough to bring it closer to the inner solar system than originally projected, closer to us. At the Deep Space Network, engineers checked for errors. Clock drift, signal delay, software bugs. Nothing explained it. The maneuver didn't violate physics. It violated expectation. Objects from interstellar space don't course correct inside a planetary system. They pass through once and leave forever. This one lingered. At Keck, observers noted that the redirection aligned the object with a region of space dense with human-made signals, satellite traffic, radar sweeps, radio leakage from Earth's surface, noise. To us, it's clutter. To something listening, it's information. As the object moved, the electromagnetic pulses changed again. The frequency spacing shifted slightly, now matching ratios seen in mathematical constants. Fibonacci sequences, prime intervals, patterns that show up in everything from galaxies to DNA. Some researchers argued this proved intelligence. Others argued it proved coincidence. But no one could argue it proved randomness. When the James Webb team overlaid the pulse data with planetary alignments, another strange alignment appeared. The strongest emissions, occurred when 3I Atlas passed through gravitational null points, regions where forces cancel out and motion becomes easier to control. Those are places spacecraft engineers love. Nature doesn't care about them. At this point, internal discussions turned from what is it to what does it want? And that's where the discomfort truly began, because wanting implies intent, and intent implies choice, and choice implies agency. If 3I Atlas was capable of choice, then it wasn't just passing through our neighborhood, it was navigating it. Once the idea of agency entered the room, it refused to leave. Scientists are trained to avoid that word. Agency carries weight. It drags philosophy into places that prefer equations. But the behavior of 3I Atlas kept forcing the issue. Every attempt to frame it as a passive object broke down under closer inspection. At NASA's Jet Propulsion Laboratory, one analyst ran a thought experiment that wasn't meant for publication. He modeled 3I Atlas not as debris, but as a system designed to conserve energy, minimize exposure, and maximize information gain. The results were uncomfortable. The object's path suddenly made sense. It wasn't taking the shortest route through the solar system. It was taking the quietest one. Skimming regions with lower particle density, avoiding high radiation. It was avoiding noise, solar flares, dense plasma streams, chaotic gravitational wells. Every place where natural objects get battered and reshaped. 3I Atlas passed lightly, like it knew where the turbulence would be before it arrived. When the model accounted for that, the object's movement stopped looking strange and started looking careful. Careful implies planning, and planning implies time. A lot of time. At the Harvard Smithsonian Center for Astrophysics, a quiet recalculation changed the emotional temperature of the discussion. If 3I Atlas had entered our system at its current velocity and followed its observed path, it could not have originated from a nearby star. Not unless it had waited between stars. Not drifting, but parked, dormant, cold. Interstellar space is not friendly to machines. Radiation damages circuits. Micrometeorites erode surfaces. Thermal extremes tear materials apart. For an object to remain intact across tens or hundreds of thousands of years, it would need either extraordinary shielding or the ability to repair itself, or both. Webb's thermal scans suggested something even stranger. When the object passed through regions of higher radiation, its internal temperature distribution subtly changed, not in a way that suggested damage, but adaptation. Heat was redirected. Sensitive regions appeared to be shielded while others absorbed exposure. That kind of response requires feedback, sensors, decision loops. It's the difference between a rock getting warm and a system managing heat. At the European Southern Observatory, someone made an offhand comment that later became hard to ignore. They said the object behaved less like a projectile and more like a seed. Seeds don't rush. Seeds endure. They survive until conditions are right, then they activate. As 3I Atlas moved deeper into the inner solar system, something else happened. Ground-based radio observatories began picking up faint anomalies during scheduled downtime. Not strong enough to trigger alerts, not consistent enough to classify, but present, short bursts, ultra-narrow bandwidth, buried under cosmic background noise. When analysts isolated the bursts and aligned them with 3I Atlas's position, the timing was exact. Every time the object passed through regions saturated with human-made radio leakage, the bursts intensified. It wasn't transmitting to us. It was sampling us. Earth is loud in radio terms. We leak signals constantly. Television, radar, satellite chatter, military communications. We don't notice it because we're inside the noise. But from the outside, our planet glows. And 3I Atlas was drifting through that glow, bathing in it, soaking it up like data. When that realization set in, the tone of internal reports shifted again. This wasn't about alien contact. This wasn't even about detection. This was about surveillance. Not aggressive, not hostile, just thorough. At Stanford, a research group revisited Ronald Bracewell's old papers on autonomous interstellar probes. The idea was simple and terrifying. A A sufficiently advanced civilization would never need to send messages. It would send listeners. Machines that don't speak. Machines that watch. Machines that wait until they understand the environment before revealing themselves, if they ever do. Bracewell called them sentinels. 3I Atlas fit the description too well. Then came the surface changes. Webb detected subtle alterations in reflectivity over time. Not erosion, not damage. Rearrangement. Patterns shifting, as if the outer layer was responding to environmental conditions. Self-reconfiguration. At Keck, adaptive optics confirmed the changes weren't artifacts. The object's surface wasn't static. It was dynamic, slowly, deliberately. The longer it stayed, the more it adjusted. At this point, the question was no longer whether 3I Atlas was artificial. The question was whether it was alone. Because the electromagnetic pulses it emitted weren't random. They were structured, efficient, optimized for long-distance travel. If it was reporting back, then somewhere out there, something was listening. And that meant the solar system wasn't just being visited, it was being checked, as if we had crossed a threshold, as if something out there had decided it was time to look closer. And if that's true, then the most dangerous moment isn't arrival, it's acknowledgement. Acknowledgement is a strange thing in space. On Earth, it's instant. A glance, a reply, a nod that says, I see you. But in the cosmos, acknowledgement takes decades, centuries, sometimes longer. Signals crawl. Light drags itself across unimaginable distances. And yet, 3I Atlas seemed to operate on a different clock. As the object crossed deeper into the heliosphere, instruments aboard Voyager 1 and Voyager 2 began recording subtle disturbances. Nothing dramatic, nothing that would ever make a headline on its own. Slight variations in plasma density, small shifts in cosmic ray intensity, the kind of data that usually gets filed away and forgotten. But when researchers at NASA compared those readings with Webb's observation windows, the timing lined up again. Every time 3I Atlas adjusted its internal activity, the outer edge of the solar system reacted. Not violently, not chaotically, more like a ripple spreading through a still pond. Voyager 1, drifting more than 14 billion miles from Earth, is no longer fully under our control. Its instruments are aging, its power is fading. And yet, during one observation cycle, its magnetometer recorded a clean, repeating oscillation that shouldn't have been there. The frequency matched the pulse, the same one Webb had been tracking. The same one once seen near Oumuamua. This time, it wasn't faint. It was clear. At JPL, engineers double-checked Voyager systems. Radiation damage, software drift, aging hardware, all ruled out. The signal wasn't internal. Voyager wasn't generating it. It was passing through it, which meant the pulse wasn't local to 3I Atlas alone. It was affecting space itself. That realization cracked open an entirely new line of thinking. What if the object wasn't just emitting signals, but interacting with the medium of space, modulating plasma, shaping electromagnetic fields, using the solar system itself as part of its communication network? That's not something rocks do. It's something advanced physics allows. At the European Space Agency, theorists began modeling exotic propulsion and communication systems, Alcubierre-style field manipulation, plasma resonance structures, quantum coherence over macroscopic distances. Most of it stayed theoretical, but the models shared one uncomfortable conclusion. If you can manipulate space at that level, you don't need engines. You don't need fuel. You move by deciding where you want to be. That would explain the silence, the lack of exhaust, the absence of thrust. 3I. Atlas wasn't pushing itself through space. It was reshaping the space around itself. That idea terrified people quietly because it meant we weren't watching something travel. We were watching something arrive. Meanwhile, Earth continued broadcasting its presence without meaning to. Every radar ping, every satellite uplink, every stray transmission leaked into the void. We've been doing this for just over a century, a blink, cosmically speaking. If 3I Atlas had been dormant between stars, waiting, then our sudden radio brightness might have been the trigger. Not a message, a symptom, a sign that something on this planet had crossed from silence into signal. And once that line is crossed, it can't be uncrossed. Webb's latest data added another layer to the unease. Infrared scans revealed transient structures inside the object that appeared and disappeared over time. Not moving parts, not machinery, fields. Zones of altered energy density that formed patterns too complex to be random. Some resembled neural networks, not brains, but architectures. Systems built to process information, adapt, and respond. If that interpretation was correct, then 3I Atlas wasn't just carrying intelligence, it was intelligence. Distributed, non-biological, possibly ancient. That raised the question no one wanted to ask openly. If this object is intelligent, what is its role? Explorer, archivist, gatekeeper, or something else entirely? At the Vera Rubin Observatory, simulations suggested that if similar objects existed, they could form a sparse network across the galaxy. Not a fleet, not an invasion, a mesh. Quiet nodes positioned along stellar migration routes, waiting for civilizations to become loud enough to notice. And once noticed, to be noticed back. Nothing in the data suggested hostility. No weapons, no aggressive maneuvers. But absence of hostility is not the same as safety. A biologist once said that when humans observe animals in the wild, we don't announce ourselves. We watch, we record, we learn. And sometimes, without meaning to, we change the environment just by being there. What if that's what's happening now? What if Earth has entered someone else's field study? As 3I Atlas continued its silent passage, one final anomaly began to surface. The pulse frequency started to drift, not randomly, gradually, sliding toward a new interval, one that matched a fundamental constant tied to hydrogen, the most common element in the universe. The implication was subtle but profound. It wasn't speaking a human language. It wasn't even speaking mathematics. It was speaking physics, a language every technological civilization must eventually learn. Which means the message, whatever it is, isn't meant just for us. It's meant for anyone listening. The shift in frequency didn't stop. Over the following days, the pulse settled into a narrow band that physicists recognized instantly, the same hydrogen transition used on the Voyager Golden Record to mark humanity's location. The same frequency astronomers have long assumed would be the universal hailing channel for intelligent life. Not because it's human, but because it's unavoidable. Any civilization that understands atoms understands hydrogen. And now, something in interstellar space was aligning itself to that truth. At the Harvard Smithsonian Center for Astrophysics, researchers overlaid the pulse timing against atomic clock standards. The match was unsettlingly tight. This wasn't a rough approximation. It was precise to a degree that required intention. The object wasn't stumbling into a familiar frequency by accident. It was converging on it, slowly, like a lock clicking into place. What followed made the room go quiet. The pulse began to phase modulate, not just repeating anymore, but changing its internal structure in response to background noise in the solar system. Solar flares altered it. Planetary magnetospheres altered it. Even Earth's own radio leakage caused minute but measurable shifts. The signal wasn't static, it was listening. And then, for the first time, it paused. A full 11 minutes of silence. No pulse, no echo, nothing. In astronomy, silence is usually comforting. It means systems have stabilized. But this silence was different. It was synchronized. Every instrument tracking the object recorded the same absence at the same moment, as if whatever process was running inside 3I Atlas had deliberately stopped. That's when the data spike hit, not from the object, from space around it. Cosmic background radiation in a tight cone ahead of 3I. Atlas dipped slightly, just enough to suggest interference. Not absorption, not reflection, redirection. Space itself was being bent, minutely, but coherently, like a lens being adjusted. At Keck Observatory in Hawaii, astronomers compared the distortion to gravitational lensing. It didn't match. The mass wasn't there. Whatever caused it wasn't gravity in the traditional sense. It was geometry, space-time behaving as if rewritten locally. The silence ended. When the pulse returned, it was different. Instead of a single rhythm, it split into harmonics. Layered frequencies stacked like chords in music. Not noise, structure, a progression. Researchers who converted the signal into audio noticed something eerie. The harmonics followed ratios found in natural resonance systems, strings, cavities, even the human vocal tract. It wasn't speech, but it wasn't random either. It was calibration, as if the object were tuning itself to the environment it had entered. At this point, internal discussions at NASA shifted tone. Not publicly, not officially, but the language changed. Memos stopped referring to 3I Atlas as an object and started calling it a system, a platform, a phenomenon. Words matter, and when scientists stop using neutral language, it's because neutrality has failed. One proposal gained traction quietly. The idea that 3I Atlas was never intended to stop, land, or interact directly. Instead, it was designed to pass through star systems, sample them, and update itself. Not a visitor, a census taker, a surveyor of intelligence. That would explain its behavior, why it didn't approach Earth directly, why it reacted to observation, why it mirrored fundamental constants instead of human symbols. It wasn't trying to talk to us. It was trying to understand what kind of universe it was currently in, and more importantly, what kind of minds had emerged here. The troubling part was what came next. Using archived Arecibo legacy data, scientists searched for historical anomalies along the same vector of space. They found them. Weak, overlooked disturbances going back decades, faint enough to dismiss, sparse enough to ignore, until now. Plot them together, and a pattern emerged. 3I Atlas wasn't the first of its kind. It was just the first we noticed. If others had passed through before, quietly sampling, quietly leaving, then Earth may have been evaluated long ago and found uninteresting. Pre-radio, pre-spaceflight, pre-noise. But now the planet glows in radio, radar, laser ranging, artificial satellites, nuclear signatures. We have altered our electromagnetic footprint in ways that are impossible to hide. From the perspective of something ancient and patient, Earth didn't suddenly appear. It woke up. And when something wakes up in a dark forest, the forest notices. As the object continued inward, its path curved, subtly. Not toward Earth, not toward the sun, but toward a region of space dense with traffic. Planets, moons, artificial satellites, probes. A crossroads of signals and gravity. The inner solar system is loud, and 3I Atlas was moving to where it could hear best. That's when the final unsettling realization began to spread through the community. If the system is adaptive, if it learns, if it updates based on what it encounters, then the most dangerous moment isn't arrival, it's departure. Because whatever it is now is not what it was when it entered. And whatever it becomes next will carry a record of us with it. By the time that idea settled in, another anomaly surfaced, Voyager 1. Not the spacecraft itself, but its telemetry history. At NASA's Jet Propulsion Laboratory, engineers reviewing long-term data noticed a subtle irregularity buried deep in Voyager 1's plasma wave readings from years earlier. At the time, it had been chalked up to background noise, a minor fluctuation during its crossing of the heliopause. But when those timestamps were compared against reconstructed models of interstellar object traffic, something chilling appeared. The anomaly lined up with a moment when an unseen mass should have passed nearby. Voyager didn't detect a rock. It detected an absence, a region where plasma density dropped sharply, then returned to normal, as if something had passed through space without displacing matter in the usual way, not pushing plasma aside, but slipping through it, like a shadow moving through fog without stirring it. That data point had been ignored for years because there was nothing to attach it to, until now. When researchers overlaid that old Voyager reading with 3I, Atlas's current vector, The geometry matched too closely to dismiss. It suggested that whatever mechanism 3I Atlas uses to move through space had been operating near our solar boundary long before we ever noticed the object itself. In other words, this thing may have been here before we named it. Not visible, not trackable, but present. That possibility reframed everything. The idea that interstellar probes announce themselves with bright flares or dramatic arrivals may be pure fiction. A truly advanced system wouldn't want to be seen until it chose to be. And now, something had chosen. At the European Southern Observatory, a team running deep simulations noticed something else unsettling. The object's path wasn't optimized for speed or fuel efficiency alone. It was optimized for information density. It passed close enough to planets to sample magnetospheres, close enough to moons to detect subsurface oceans, close enough to Earth to bathe in radio noise, yet never close enough to risk capture. That balance isn't accidental. It's cautious. Caution implies stakes. As the object moved through regions saturated with human-made transmissions, its emissions subtly increased in complexity. Not volume, structure, more layers, more harmonics, more internal variation. It was updating its model of us, every radar sweep, every satellite ping, every deep space transmission added detail. And here's the part that disturbed researchers the most. The signal complexity increased fastest when military radar systems were active. Not civilian broadcasts, not television or internet chatter targeting radar, tracking arrays, early warning systems, the kind of signals designed to find objects. 3I Atlas appeared to respond most strongly when we tried to look for threats. That doesn't mean it's hostile, but it does mean it understands what we fear. A quiet debate erupted behind closed doors. Not about aliens, but about disclosure. How do you explain an adaptive interstellar system to the public without triggering panic? Especially when you can't say what it wants, where it came from, or whether it even notices us as individuals. Because if this is a surveyor, then we are not a conversation partner. We are a data point. And data points don't get warnings. They get recorded. Another recalculation tightened the knot further. Based on its current trajectory and velocity changes, 3I Atlas will exit the inner solar system with more energy than it entered. Not enough to violate physics outright, but enough to suggest energy harvesting. Slingshot effects alone can't explain it. It gained something while it was here. Not mass, not fuel, information. That's when a phrase started appearing in internal notes. Not officially, not in press releases, but scribbled in margins and whispered in corridors. Final transmission. Not because it was sending us a message, but because it was finishing its upload. If the system is part of a network, if it reports back, then the most important moment is not when it arrives, it's when it leaves. Because whatever intelligence designed, it will receive a snapshot of us as we are now. Loud, curious, armed, fragmented, brilliant, afraid. And that snapshot will persist long after 3I Atlas fades back into interstellar darkness. At that point, the question stops being, what is it? And becomes, what will be done with what it learned? The universe doesn't rush. Civilizations don't either. And if something has been watching patiently, the scariest possibility isn't invasion, it's evaluation. What made that idea harder to ignore was the timing. As 3I, Atlas approached the point of maximum informational exposure, where planetary gravity, artificial satellites, and human transmissions overlapped most densely. Its internal activity peaked, thermal pulses tightened, emissions became cleaner, noise dropped. The system wasn't overwhelmed by the chaos of the inner solar system. It thrived in it. At the Vera Rubin Observatory, researchers testing early alert algorithms noticed that the object's reflectivity changed most rapidly when multiple observation platforms focused on it at once. Space-based telescopes, ground arrays, radar sweeps. The more eyes on it, the more its surface patterns reorganized. As if compensating for scrutiny, it didn't hide, it adapted. That distinction matters. Hiding is fear. Adapting is intelligence. In archived Hubble spectrograph records, analysts found a faint echo. A short-lived absorption anomaly years before 3I Atlas was formally identified. At the time, it had been dismissed as instrumental drift, but when recalculated with current models, the anomaly aligned with a hypothetical earlier pass of the same object, farther out, colder, quieter. That suggested something unsettling. 3I Atlas didn't just arrive and activate. It approached in stages, dormant, semi-active, fully engaged, like a system waking up as environmental thresholds were crossed. At Stanford, a theoretical group revisited Bracewell's concept again, this time adding something new. What if these probes aren't looking for biology alone? What if they're tuned to detect technological inflection points, moments when a species crosses from passive existence into active manipulation of its environment? Radio leakage, orbital infrastructure, artificial nightlights, energy concentration. From that perspective, Earth didn't become interesting because it hosted life. It became interesting because life here started changing the planet faster than nature alone ever could. The emissions from 3I Atlas showed particular sensitivity to tightly focused beams, lasers, LiDAR, high-gain antennas, directed energy, systems designed not just to broadcast, but to aim. That suggests recognition, not of us as individuals, but of capability. If you're designing a long-term survey of the galaxy, you don't need to worry about microbes. You worry about tool makers, species that reshape their surroundings, species that build things that persist, species that might eventually notice you back. As the object neared its point of closest informational pass, something unprecedented happened. For the first time, a deviation occurred that could not be attributed to gravitational influence, radiation pressure, or measurement error. A pause. For nearly 4 minutes, its velocity relative to surrounding space flattened. Not stopped, but smoothed, as if it were hovering inside a stream rather than flowing through it. Physics didn't break, but it bent in a way that required an explanation no one could comfortably provide. During that interval, signal complexity peaked, not outward, inward. The emissions folded into themselves, harmonics stacking tighter and tighter, collapsing into a narrow band before disappearing entirely. Silence again. But this silence was different from the first. It wasn't passive. It felt complete. When the signal returned, it had simplified. Less variation, less responsiveness. Like a system that had finished gathering what it needed. At the Keck Observatory, one astronomer wrote a single line in their notebook that later circulated quietly among colleagues. It's done listening. And that's when the implications became unavoidable. If this was a surveyor, if it collected data and then departed, then the next phase of whatever process this belongs to wouldn't happen here. It would happen elsewhere, far away, beyond our reach, beyond our influence. Meaning whatever conclusions were drawn about Earth, about humanity, about our trajectory, would be made without our input. We wouldn't get a chance to explain ourselves, or to object, or to ask questions. Because from the perspective of something ancient enough to build interstellar sentinels, a century is a blink. A millennium is patience. And silence is not absence. It's deliberation. And then the models broke. Not catastrophically. Not in a way that made alarms ring. They simply stopped agreeing with each other. Independent simulations run at NASA's Jet Propulsion Laboratory, the European Southern Observatory, and a university group in Tokyo all began to diverge after the same timestamp. Before that moment, every model predicted roughly the same outbound path for 3I Atlas. After it, the solutions fanned out like cracks in glass. Small differences at first. A few thousand kilometers here, a few degrees there. But when projected forward over decades, the spread became enormous. Something had changed the boundary conditions. In plain terms, the object's future path could no longer be predicted using known physics alone. That realization forced a hard admission. Whatever maneuver 3I Atlas executed during its moment of silence altered more than its trajectory. It altered how it interacted with space itself, as if the rules applied to it had shifted just slightly, just enough to break our equations. At Caltech, a physicist quietly proposed an idea that no one wanted to put in writing. What if the object isn't moving through space the way we move through it? What if it's modifying its local frame, creating a pocket where distances and time behave differently, not faster than light travel, something subtler, a controlled reduction of interaction, like lowering friction rather than increasing speed? If that's true, then what we're watching isn't propulsion. It's disengagement. The object isn't leaving faster, it's touching us less. That would explain the lack of exhaust, the absence of outgassing, the way plasma flows around it instead of colliding. It doesn't push the universe aside, it asks the universe to step around it, and the universe complies. As this idea circulated, another unsettling pattern emerged. The object's emissions, which had grown complex during its passage through the inner solar system, were now simplifying, not degrading, compressing, like raw data being summarized. That's what happens at the end of a recording session. You don't keep every detail, you keep what matters. At the Harvard Smithsonian Center for Astrophysics, a linguist turned data scientist ran the signal structure through compression algorithms used in biological systems. The result wasn't a translation, but it was revealing. The signal showed hallmarks of semantic prioritization. Certain patterns were preserved at higher fidelity than others. Not planets, not stars. Us, our electromagnetic behavior, our reaction times, our observation patterns, our attempts to classify and control. It wasn't studying chemistry, it was studying behavior. That reframed everything yet again. The object wasn't cataloging resources or environments. It was observing responses, how a technological species reacts to the unknown, how quickly it notices, how aggressively it observes, how it behaves when it cannot control what it sees. From that angle, 3i Atlas didn't need to communicate. It already had the answers. As the object drifted past the region of highest observational density, its surface stabilized. The adaptive changes slowed, then stopped entirely. Whatever configuration it had reached, it kept, like a final form. At the Vera Rubin Observatory, someone noticed something that made their stomach drop. The stabilized surface geometry matched a configuration that maximized reflection away from the inner solar system and toward the outbound vector. It wasn't hiding from us. It was turning outward, preparing to transmit, not a message we could hear, a report we would never receive. The last faint emission detected from 3i Atlas wasn't a pulse. It wasn't a harmonic. It wasn't even electromagnetic in the conventional sense. It was a subtle, coherent distortion in the cosmic background, a ripple so clean it almost blended into the universe's own noise. Almost enough to confirm that something had been sent, and then the object began to fade, not visually, conceptually. As its interaction with our instruments diminished, it became harder to measure, harder to pin down, harder to track. Like trying to follow a shadow as the light source changes. It wasn't vanishing, it was withdrawing. At that moment, a question surfaced that no model could answer. If this was a surveyor, if it had completed its task, then what determines what happens next? Is there a threshold beyond which observation turns into intervention? And if so, did we just cross it? Because the most unsettling part isn't that 3i Atlas came here. It's that it left changed. And whatever it becomes next will carry a version of us into the dark. Not our stories, not our art, not our hopes, but our reactions, our fears, our readiness, and somewhere, far beyond our telescopes, that record will be judged. Not quickly, not emotionally, but carefully. And patience in the universe is power. The waiting began after that. Not public waiting, not the kind that makes headlines or countdown clocks. This was the quiet, uncomfortable waiting that happens when every instrument is still pointed outward, but nothing new comes back. When the graphs flatten, when the alerts stay silent, when the universe, after brushing past you, resumes its indifference. Except it didn't feel indifferent anymore. At NASA's Deep Space Network, engineers noticed something subtle in the weeks following 3i Atlas's withdrawal. Background noise levels dropped by a fraction of a percent. Not enough to matter operationally, not enough to alarm anyone, but enough to notice if you had been staring at the same data for decades. Space sounded cleaner, as if a listener had left the room. That was unsettling on its own. But then came the follow-on effect. Certain long-range radar experiments began producing slightly different echo profiles. Not failures, not distortions, just a faint loss of coherence at extreme distances. Signals that should have returned with predictable scatter came back smoother, simpler, almost filtered. At first, engineers blamed calibration drift, aging equipment, solar conditions, anything ordinary. But when multiple systems in different countries reported the same anomaly, the explanation thinned. It was as if the interstellar medium itself had been updated. That idea never made it into official reports. It lived in margins, side conversations, and late-night emails that began with, "This is probably nothing, but..." Because if 3I, Atlas, was capable of interacting with space at a structural level, even briefly, then its passage may have altered local conditions in ways we don't yet know how to measure. Not damage, not destruction, imprint, like footsteps in soft ground that slowly disappear, but not immediately. Another disturbing correlation emerged from archival data. Astronomers re-examining unexplained fast radio bursts noticed a weak clustering pattern aligned with the outbound vector of 3I, Atlas. The bursts themselves were unrelated in origin, coming from distant galaxies, but their arrival times showed a slight statistical bias, as if something moving outward was passing through regions where those signals propagated, like ripples crossing ripples. This didn't mean 3I, Atlas, caused them, but it meant it was now part of the map. At the Harvard Smithsonian Center for Astrophysics, a senior researcher said something that stopped the room cold. They said, "We might be thinking about this backwards, that we keep assuming these objects visit us to learn about us. But what if the real function is synchronization? In complex systems, especially biological and computational ones, there's a moment when independent nodes align. They don't communicate directly, they don't exchange messages, they simply adjust until they operate within compatible parameters." Maybe 3I. Atlas wasn't asking who we are. Maybe it was checking whether we are compatible with something larger. That idea reframed the silence that followed. The lack of response wasn't rejection. It wasn't indifference. It was a pause while systems elsewhere adjusted. If that's true, then the most important data didn't come from 3I, Atlas itself. It came from us, from how we reacted, how quickly we noticed, how aggressively we observed, how much we tried to control the narrative. Every civilization, at some point, reaches a stage where it realizes the universe is not empty. The question is not whether that moment comes, it's how the civilization behaves when it does. Do they panic? Do they weaponize curiosity? Do they assume threat before understanding? Or do they listen? From the outside, those choices are measurable. And 3I, Atlas, was very good at measuring. As months passed, its predicted position drifted beyond the sensitivity of most instruments. Not because it was too far, but because it no longer interacted strongly enough to be distinguished from background structure. Only the most sensitive arrays could still trace it, and even then, only as a statistical presence. A probability, a suggestion. The universe, it seemed, was closing the door quietly. But doors that close can open again. Because one last recalculation, buried deep in a joint paper between JPL and ESO, hinted at something that hadn't fully sunk in yet. Based on energy conservation and interaction models, 3I, Atlas, could not have completed its outbound transition alone. Something met it, not visibly, not explosively, but mathematically. A region where variables changed too smoothly, too cooperatively, as if a handoff had occurred. That implies this object was not operating independently. It implies coordination, and coordination implies a network, which means 3I, Atlas, was never the event. It was the handshake, and handshakes are never the end of a story. They are how something begins, After that realization settled in, the tone changed everywhere. Not in press releases. Those stayed careful, padded with words like anomaly, uncertainty, ongoing analysis. But behind closed doors, among the people who had followed the data from the beginning, the language became more honest, more human, less technical. They stopped asking what 3i Atlas was. They started asking when the next one would arrive. Because once you accept the idea of a network, the idea of a single visitor makes no sense. Networks don't send one node. They test, they relay, they observe. Then they decide whether to continue. That meant 3i Atlas was not an endpoint. It was a threshold marker. At the European Southern Observatory, long baseline sky surveys were quietly reprioritized, not to search for fast movers or bright intruders, but for slow discrepancies. Objects that didn't announce themselves. Objects that blended into background motion so well they only stood out when you subtracted what times should times be there. That shift alone says everything. We stopped looking for aliens. We started looking for intent. One of the most uncomfortable findings came from an unexpected place. Not from telescopes, but from mathematics. A team at Stanford, revisiting Ronald Bracewell's old probe hypothesis, noticed something eerie. Bracewell proposed that advanced civilizations would send autonomous probes that remain silent unless a planet reaches a specific technological stage. What few people remembered is that Bracewell also predicted a second phase. A phase where probes do not communicate at all, but instead modify observation conditions, shaping how a civilization sees the universe before contact. A filter, the changes in background noise, the smoothing of signal returns, the subtle loss of coherence at extreme ranges. All of it fit that model uncomfortably well. Not interference, calibration, as if something adjusted the resolution of our window outward. If that's true, then 3i Atlas didn't just observe us. It updated the interface. And once you start thinking that way, small things become terrifying. Like the fact that certain deep field surveys now return slightly fewer anomalies than expected. Not zero, just fewer. As if the universe beyond a certain depth has become more orderly, less noisy, less chaotic. The universe isn't supposed to do that. Chaos is the baseline. Order requires work. At the same time, something else increased. Precision. Our instruments became more consistent. Our measurements cleaner. The same tools, the same hardware, but with results that suddenly agreed with each other more often than before. That sounds like progress. It didn't feel like it. It felt like being placed in a sandbox, a controlled environment where variables behave nicely so you can learn faster. But sandboxes are not where you live forever. They are where you are evaluated. And that raises the most unsettling question of all. What is the evaluation criteria? Energy usage? We broadcast constantly now. Radar, satellites, communication beams pouring into space non-stop. If silence is intelligence, we failed that test decades ago. Curiosity? We passed that easily. We pointed everything we had at 3i Atlas the moment we noticed it. Restraint? That one is harder to answer. Within weeks of confirming its artificial traits, classified programs attempted interaction. Scans, probes, active measurements. We didn't wait, we never do. From an outside perspective, that behavior might look less like intelligence and more like reflex. A startled animal rushing the noise. If 3i Atlas was part of a long-running survey, then Earth just revealed a lot about itself in a very short time. And surveys don't exist without follow-ups. One quiet detail from James Webb's final observation pass continues to trouble researchers. Just before the object slipped below confident detection thresholds, its infrared signature flattened completely. Not cooled, not dimmed, flattened, meaning energy distribution across its structure equalized almost instantly. That's not how matter behaves naturally. That's how systems shut down before transfer. As if whatever computation, storage, or processing was occurring locally had finished and offloaded. You don't shut down a device mid-task. You shut it down when the task is complete. So if that task was observation, then the observation is over. And whatever conclusions were drawn are no longer here. They're somewhere else. Which brings us to the part no one likes to talk about: timing. In astronomy, timing is everything. Orbits, cycles, windows, alignments. The arrival of 3I Atlas coincided with a very specific moment in human history. We had just crossed multiple thresholds at once: planet-scale computation, persistent artificial intelligence, self-replicating manufacturing systems, the ability to alter our planet's chemistry deliberately. From a cosmic perspective, that's not gradual progress. That's ignition. Civilizations don't get interesting when they invent tools. They get interesting when they stop being confined to their origin. And we are right there. If 3I Atlas was watching for that moment, then its arrival was not early. It was right on time. Which means the silence that followed is not the end of the story. It's the gap between acts. And in space, gaps are never empty. They are where momentum builds. They are where decisions propagate. They are where something else begins to move. And here's where the story takes a turn that even the most cautious scientists struggle to explain away. Because while 3I Atlas faded from our instruments, the solar system itself didn't return to normal. Subtle changes began showing up in places no one had connected before. Tiny timing offsets in pulsar-based navigation systems. Not enough to break anything. Just enough to notice if you were already looking closely. The same pulsars we use as cosmic clocks, mapped and trusted for decades, suddenly disagreed with each other by fractions of a millisecond. That shouldn't happen. At the Harvard Smithsonian Center for Astrophysics, one researcher described it quietly as a phase wobble. Not an error, not noise, a shift, as if the reference frame itself had been nudged. At first, it was blamed on calibration drift, then on software updates, then on solar interference. But none of those explanations held up when the same offsets appeared in data pulled from completely independent systems, including archived Arecibo legacy observations and Voyager 1 telemetry records, stored long before 3I Atlas was even discovered. The implication was chilling. Whatever changed did not begin when we noticed it. It began when something passed through. That realization forced a deeper question. What if 3I Atlas wasn't just observing from the outside? What if its real interaction wasn't optical, thermal, or electromagnetic at all? What if it interacted with the substrate we measure space itself against? In physics, there's an uncomfortable truth most people never hear about. Space is not empty. Time is not fixed. They're flexible, responsive, and under the right conditions, programmable. We know this from gravitational waves, from relativistic lensing, from quantum field behavior. Advanced enough technology wouldn't need to shout. It would rewrite the environment quietly. At NASA's Jet Propulsion Laboratory, a small internal modeling group began running simulations they never expected to publish. Models where a passing object doesn't communicate directly, but instead seeds long-lived distortions into orbital mechanics, signal propagation, and probability distributions. Effects so small they look like background variation, until they add up. That's when a terrifying pattern emerged. If you take those distortions and project them forward, they converge, not on Earth, on a window roughly 2 to 3 decades ahead. A point where multiple unrelated systems, technological, astronomical, and even ecological, intersect in a way that maximizes sensitivity. In other words, a moment when a civilization becomes easiest to influence without direct contact. That's not invasion, that's guidance, or steering. And once you consider that possibility, the behavior of 3I Atlas makes perfect sense. The silence, the lack of response, the absence of any clear message. It didn't come to talk to us. It came to adjust the stage. Think about it. If you wanted to study how a species reacts, you wouldn't announce yourself. You would change one variable and watch the outcome. Nudge conditions, observe adaptation, measure resilience. Earth, right now, is incredibly reactive. We respond to pressure fast. Too fast. Economic shifts, climate anomalies, technological breakthroughs. We pivot constantly. That makes us informative. It also makes us predictable. And predictable systems are easy to model. One of the final data points that keeps resurfacing comes from an odd source. The Keck Observatory in Hawaii, during a routine calibration check, weeks after 3I Atlas faded, recorded a transient interference pattern in its adaptive optics system. It lasted less than a second, too brief to classify, but when the raw wavefront data was examined later, it showed a phase inversion pattern identical to one produced in laboratory experiments involving space-time metric manipulation. Experiments that, until now, only existed on paper. No announcement was made, no paper published. The data was quietly archived. But among those who saw it, the conclusion was unavoidable. Something had passed through the local space-time fabric and left a fingerprint. Not damage, a signature. And signatures exist to be recognized. Which brings us to the hardest truth to accept. What if the transmission we keep talking about wasn't electromagnetic at all? What if it wasn't meant for radios, telescopes, or sensors? What if it was meant for systems like us? Civilizations capable of detecting subtle inconsistencies, of noticing when the universe behaves just slightly differently than it should, of asking the wrong questions at the right time. In that sense, the transmission already worked. We noticed, we changed our behavior. We reoriented our science. We began watching differently. And that might be the only confirmation required, because if 3I Atlas is part of a larger intelligence, then direct contact would be inefficient, dangerous, limiting. Much better to let a civilization reach out on its own terms, guided by breadcrumbs it doesn't even recognize as such. That's the part that keeps researchers awake at night. Not the idea that something is coming, but the idea that nothing else needs to, because if the goal was to trigger a process, not an arrival, then Earth is already inside it. And the universe doesn't rush processes like that. It waits, it observes, and it lets the outcome unfold. And once you accept that possibility, the quiet details stop looking random and start lining up in ways that are hard to ignore. In the months following 3I, Atlas's closest observational window, several long-running experiments began returning results that didn't fit historical baselines. Not dramatic failures, not breakthroughs, just slight drifts. Subtle changes that only stood out because some of these experiments had been running unchanged for decades. At the European Southern Observatory, astronomers comparing stellar parallax measurements noticed minute discrepancies in distance calculations for stars near the ecliptic plane. The differences were tiny, well within error margins if viewed alone. But when plotted over time, they formed a smooth curve, not noise. A curve that began exactly when 3I Atlas entered the inner solar system. At first, the explanation was simple. Instrument aging, atmospheric modeling updates, human bias, all reasonable, all comforting. Until the same curve appeared in data from space-based platforms that don't share those limitations. Hubble spectrograph records showed a faint but consistent phase lag in ultraviolet observations. The James Webb Space Telescope, operating in infrared, showed the same lag, scaled differently, but unmistakably related. Even Voyager 1, now drifting beyond the heliopause, recorded a transient change in cosmic ray density that didn't match any known solar or interstellar event. These systems don't talk to each other. They don't share clocks, software, or calibration methods, and yet they all twitch the same way. That's when the conversation shifted from what is it to what did it do? One hypothesis began circulating quietly among theoretical physicists, not in press releases, but in handwritten notes and private calls. The idea was unsettling in its simplicity. 3I, Atlas, may have functioned as a reference adjuster, not a probe that scans objects, but one that recalibrates environments. In computer science, there's a concept called a seed state. You don't control every variable directly. You introduce a carefully chosen starting condition and let the system evolve on its own. Complex systems like weather, economies, or ecosystems respond dramatically to small, precise changes. The universe, it turns out, might be no different. If you slightly alter how space-time propagates information locally, even by an unimaginably small amount, you don't see instant chaos. You see delayed consequences. shifts in probabilities, increased sensitivity to certain outcomes. And humanity, right now, lives entirely inside probability. We depend on predictions, on stable assumptions, on the idea that tomorrow behaves roughly like yesterday. Disrupt that gently enough, and you don't break a civilization. You test it. At Stanford, a research group revisiting Ronald Bracewell's early ideas on autonomous interstellar probes found something eerie in his old notes. Bracewell had proposed that advanced probes wouldn't reveal themselves openly. Instead, they'd sit quietly, waiting for a civilization to reach a point where it could detect anomalies in the fabric of reality itself. Only then would contact become meaningful. At the time, it sounded like science fiction. Now, it sounds uncomfortably accurate. Bracewell argued that intelligence reveals itself not by building radios, but by noticing inconsistencies, by asking why the universe doesn't behave exactly as expected. A species that shrugs at anomalies isn't ready. A species that obsesses over them might be 3. Atlas didn't send a greeting. It sent an inconsistency. And once that idea took hold, another unsettling pattern emerged. The anomalies weren't evenly distributed. They clustered around regions of high technological activity, dense satellite constellations, deep space communication hubs, planetary radar installations, places where humanity stretches its awareness beyond Earth. As if whatever adjustment occurred was being amplified by our own infrastructure. We became part of the circuit. That raises a deeply uncomfortable question. What if intelligence doesn't arrive from the outside at all? What if it emerges through interaction? What if advanced civilizations don't invade or contact, but instead modify the conditions under which younger civilizations think, innovate, and evolve? In that model, 3I Atlas isn't a scout or a messenger. It's a catalyst, and catalysts don't stay. They pass through, do their work, and leave the system to react. That would explain the object's indifference to observation, the lack of response to signals, the absence of any clear attempt at communication. It wasn't waiting for us to say hello. It was waiting for us to notice the change. And now we have... The troubling part is that once a system enters a new regime, you can't rewind it. You can't unsee an anomaly. You can't return to believing the universe is passive once it demonstrates otherwise. Science doesn't forget. Civilizations don't forget. From this point forward, every unexpected fluctuation, every unexplained signal, every statistical oddity will be viewed through a new lens. Not as isolated mysteries, but as potential after effects, echoes, which leads to the most unsettling possibility of all. What if 3I Atlas wasn't unique? What if it wasn't the first? And what if it wasn't the last? Not because more objects are coming, but because once a civilization becomes sensitive enough, it begins to notice what was always there. The universe may be full of these quiet mechanisms, dormant, subtle, waiting for minds capable of detecting them. Not predators, not gods, but engineers of emergence. And if that's true, then the real transmission wasn't a signal sent through space. It was a question posed to us. Are you paying attention yet? Because from the moment we answered yes, the story stopped being about 3I Atlas and started being about us. And once the story turns inward like that, there's no clean place to stop it, because the effects don't announce themselves all at once. They seep in quietly through places we weren't looking. One of the strangest follow-ups didn't come from astronomy at all. It came from mathematics. A small group of researchers working on complex systems theory noticed something odd while modeling long-term probability distributions. Their simulations, which had behaved consistently for years, began converging faster than expected, not collapsing, not breaking, just resolving more efficiently, as if the solution space itself had become smoother. At first, they blamed software updates, then hardware, then human bias. But when older archive models were rerun on isolated systems and produced the same new behavior, the unease began. The math hadn't changed. The assumptions hadn't changed. The environment had. In physics, environment matters. Fields matter. Background structure matters. We often treat space as empty because, at human scales, it mostly behaves that way. But at cosmic scales, space is a medium. a fabric, a thing with properties, and those properties can, in theory, be nudged. At the Jet Propulsion Laboratory, one analyst made a comment that never appeared in any report. They said it felt like the universe had been slightly retuned, like tightening a string on an instrument by a fraction too small to hear directly, but enough to change the harmony. That metaphor stuck, because harmony is not about force. It's about alignment. Another overlooked detail surfaced in radio astronomy archives. Several observatories, including the remnants of Arecibo's legacy datasets and newer arrays in Australia and South Africa, showed a brief increase in signal coherence during the same window when 3I Atlas was most active, not stronger signals, clearer ones, as if interference had momentarily decreased. That shouldn't happen. The sky is noisy, always has been. Galactic radiation, solar activity, human interference. You don't get cleaner skies by accident. Unless something reduces noise, noise in information theory is what hides structure. Reduce it, and patterns emerge. And humanity, whether we realize it or not, is obsessed with patterns. We look for them in stars, in equations, in stories, in meaning itself. So here's the uncomfortable thought that began circulating quietly in closed circles. What if 3I Atlas didn't bring information? What if it removed obstacles to seeing information that was already there? That would explain why nothing overt happened. No landing, no message, no undeniable proof. Instead, we got enhanced sensitivity, a civilization upgrade without permission. From that perspective, the object didn't confirm our fears. It confirmed our readiness, or at least tested it. This aligns disturbingly well with a long-ignored idea in astrobiology, the Great Filter. The concept that something prevents most civilizations from advancing far enough to become interstellar, usually framed as catastrophe, war, self-destruction. But there's another version of the filter that rarely gets discussed. What if most civilizations fail not because they destroy themselves, but because they fail to notice the transition point? What if they miss the moment when the universe stops being passive and starts responding? A species that never looks closely enough would never realize anything changed. A species that looks too aggressively might panic. Only a narrow band would respond with restraint, curiosity, and patience. Those traits are measurable. 3I Atlas may have been measuring them. That possibility reframes a lot of human behavior over the last few years. Our rush to classify, to claim, to dominate narratives, our instinct to weaponize uncertainty, our discomfort with silence. Silence is hard for us. We fill it with speculation, fear, noise, but advanced systems don't rush, they wait. And that brings us to something even harder to accept. If 3I Atlas was evaluating us, then the evaluation isn't over. Because evaluation doesn't end when the probe leaves. It ends when the system stabilizes. We are still stabilizing. Every new telescope we build, every deeper scan, every algorithm designed to find meaning in chaos is now operating in an environment that may no longer be neutral, and we don't know the rules yet. That's the most unsettling part. Not that something came, but that something may have quietly changed the conditions under which discovery itself happens. From now on, every breakthrough carries an asterisk. Did we find this? Or were we made able to find it? That question will haunt science for generations. Because once the universe stops behaving like an empty stage and starts behaving like an interactive system, the old boundaries collapse. Observer and observed blur. Discovery becomes dialogue. And intention, once introduced, never fully leaves the equation. We are still listening, but we don't yet know what we're listening for. And until we do, the silence left behind by 3I Atlas may be the loudest signal we've ever received. And then came the realization that stopped the debates cold. Not because of a new signal, not because of a new image, but because of what didn't happen next. Nothing arrived to finish the story. No follow-up object, no escalation, no correction, no second message to clarify the first. The universe did not explain itself. It simply continued, as if waiting to see what we would do with the discomfort it had just introduced. That's when a quiet consensus began to form among a handful of senior scientists across NASA, Jet Propulsion Laboratory, the European Southern Observatory, and independent theorists tied loosely to the Harvard-Smithsonian Center for Astrophysics. The most important phase of the event was not the detection of 3I, Atlas. It was the aftermath. Because if the object truly functioned as a trigger, a calibration pass, or a handshake, then the climax wasn't its arrival. The climax was us realizing we were being measured by how we reacted once it was gone. Every choice after that moment mattered more than anything before it. Whether we rushed to weaponize uncertainty or slowed down to understand it, whether we framed the unknown as an enemy or as a mirror, whether we demanded answers or learned how to sit with better questions. The final transmission from 3I, Atlas, may not have been electromagnetic at all. It may have been behavioral. A test written in silence, graded over time, evaluated not by what we heard, but by what we did when there was nothing left to hear. And that's the part no one wanted to say out loud. If something out there wanted to know whether humanity was ready, it wouldn't ask us directly. It would give us just enough information to destabilize our assumptions and then watch what emerged. Fear or patience, control or curiosity, noise or restraint. Those are answers you don't get from signals. You get them from outcomes. So maybe the most unsettling truth isn't that something intelligent passed through our solar system. It's that it may already have what it came for. And now, somewhere beyond our reach, a conclusion is being drawn. If that's the case, then the story of 3I, Atlas, isn't over. It's paused. And what happens next depends entirely on how we behave while we think no one is watching. If you want to stay with this story as it unfolds and see what comes next, subscribe now and watch the next video on your screen, because this chapter may be finished, but the consequences are just beginning.